This is from exam 2, the 3 reactions. Keep in mind they have to be net ionic. So let's see. Solid sodium oxide, Na2O, is added to water. Well, a metal oxide in water is going to give me the charged metal and the hydroxide ion, and I just have to make sure it's balanced. So when I do this, I'm going to make 2 OHs and 2 NAs. Looking at 2, a solution of copper 2 chloride is added to a solution of sodium sulfide. So copper 2 chloride, sodium sulfide. Well, looking at this, it's definitely going to be a double replacement, which makes me think that it's going to be some precipitation reaction. So if I look at this, sodium chloride, definitely going to be aqueous because it dissolves in water. My guess is copper sulfide will be the solid. So if I do that, I know that the Cu2 plus Cl minus, there are 2 of them, plus Na, there are 2 of them, plus S2 minus, gives me Na plus, because it's aqueous, it divides up, Cl minus, Cus is a solid. So now my Nas and my Cls go away, Cu2 plus S2 minus makes copper sulfate solid. That would be the net ionic part that I have to do. Part 3. A sample of solid iron 3 oxide is reduced completely with solid carbon. So iron 3 oxide with solid carbon. If it's reduced completely, this right now, it's an iron 3. So iron reduced completely. Reduced means that it gains electrons. That's the Ger part. So if it's reduced completely, it's going to gain 3 electrons and become Fe with no charge. So I know I'm going to make iron. And what that means, if I'm thinking about a single replacement here, the oxygen is going to go with carbon. Now in this case, I can make it form carbon dioxide or carbon monoxide. I can't have CO3 because that doesn't make any sense. CO3 is carbony with a 2 minus charge. The only carbon-oxygen compounds that make sense with no charge, carbon monoxide or carbon dioxide. So if I do it that way, I just have to make sure I balance it correctly with redox. Fe2O3 goes to Fe. Well, I know I need to add 3 waters, so then 6 hydrogens. So if I then do my charge, sorry, my phone is ringing. So I need 6 electrons on this side as well. See? And now I have carbon goes to CO2. I need 2 waters. And then 4 hydrogens. And then I need 4 electrons. Well, I got to make both of these 12. So that means I'm going to multiply everything here by 2. So that would be 12 H's, 2 of those, 12 electrons, 2 of those, and then 6 of those. Multiply everything here by 3, so 6 waters. Let's see, 3 carbons, 3 CO2s, 12 H's, 12 electrons. My H's, my electrons, and my waters all ended up canceling. So I'm left with 2 Fe2O3, 3 C, 3 CO2, 2 Fe. Now, if you did the one with carbon monoxide, it would be balanced a little differently, but that's still okay.